So in this video, we're going to look at a model or hypothesis about risky choice, which is called expected utility theory. So this follows from ideas about expected value theory and hopefully solves some problems that theory had. So let's take a very high level view of how expected utility theory works. So what we'll see here in our example of a risky choice is that we have the black box and we are presenting stimuli to the black box. So do you want 100% chance of getting £100 or do you want 20% chance of £1,000? And obviously expected utility theory is essentially trying to do a better job of explaining what is going on in this box in order to give rise to a choice that is made. So if we take a look, initially this might look rather complicated, but if you refer to my video on expected value theory, you'll see that actually there's a very, very small difference here. So let's just think about this bottom example of how do you calculate the expected utility of 20% chance of £1,000. What you would do simply is you basically work out, well, what is the expected utility? So we have two outcomes here. There's a 20% chance of winning £1,000 and there's an 80% chance of winning nothing. Now, if this were expected value theory, we would basically work out what is 20% of £1,000. So the answer, the expected value would be £200. But this isn't expected value theory, this is expected utility theory. And so what we would do is we would consult our subjective utility function, and maybe you need to refresh your memory from the video I did about subjective utility. But what we're talking about here is subjective utility is an internal representation of how useful is £1,000 to me. And we saw that Bernoulli proposed this curve which goes up. So as the amount of money goes up, the amount of utility you get from that increases, but the more and more money you get, the less additional benefit you get. And so that's represented in the shape of this curve, which essentially is flattening off somewhat. So what you would do is you would say, aha, right, they're talking about £1,000. And so your brain would essentially calculate what is the utility of £1,000 to me. So you can see what you might do is look up £1,000 on the x-axis, trace this up, the curve up to where it meets the curve, and then go left to the axis, and you would work out, aha, it has this much utility to me. And I'm not going to come up with a number. You don't necessarily need a number, but you can if you want. But the point is here is that £1,000 is a lot, so that's far over on the axis here. And so in general, what we're saying is that the subjective utility of £1,000 is high. But then, of course, that would tell you the expected utility of this risky choice of 20% chance of 1,000. But you've got to then compare that to the other choice that we have here, which is a sure choice of £100. And so this can be broken down into, well, first of all, we can consider, we can kind of ignore the idea of winning 0 because you will win, you will get 100. But we want to calculate what is the expected value, the expected utility of £100. So again, you're brain in this scheme would work out what is the value here on the y-axis. What is the expected? What is the utility of £100? And so on this schematic curve, you can see that this is actually going to give you some utility, but it's going to be much less than if you got £1,000. So in this particular example, that I haven't kind of gone through all the numbers, but in this particular example, you're calculating the utility of each outcome, and you're picking the choice which gives you the highest expected utility.